So in this video we're going to have a look at some programming tips that you can use to manipulate numbers. So we've previously looked at variables and the fact that we can store text and we can store digits, for example. But what we can't do is join these two together. So if I say name plus number, for example, when I run that program, it'll say no. It'll say it must be a string, not an integer. So the first thing, and probably the most likely thing you're going to want to do with your numbers, is actually turn them into text just for display purposes. And once you turn them into text, you can do other things such as find out the lengths using the len command. So that works. You might want to put a space in there, for example. So that's one thing that you can do. When we're doing calculations, one thing you might have noticed is that Python doesn't support square roots. There's no square root command built in. So you can use a library function, but you can also take advantage of powers and indices. So if you haven't come across this before, so you obviously can do multiplication. So you can do 2 times 3, for example, or 2 times 2. We can do division. So 3, we use a slash. We use plus and minus for the standard symbols for plus and minus. But to raise one number to a power of another number, so if I wanted to do 4 squared, for example, I can do 4 squared like so. So I use 2 asterisks or 2 stars, and that indicates a power. So that's 4 to the power 2. 2 to the power 3 would be like so. So if you're doing GCSE maths as well, so if you're at school, you'll be familiar with the idea that a root can be represented by a fraction. So something to the power of a half is a square root, something to the power of a third is a cube root, something to the power of a fourth is, or quarter, is a fourth root, etc. So we can take advantage of that idea. Python can cope with that, so you can find a square root without importing the square root function. So if you did 25, for example, to the power of 0.5, so you put in the decimal equivalent, it'll cope with that. So it's telling us that the square root of 25 is 4, so that's quite a useful thing. Sometimes if you're programming something with movement, so certainly you might have come across this in Scratch, so you might have a direction and a movement, but if it's going, say, left, you might end up with a negative speed, for example. So a useful function is one called abs, which gives you your abs. It's called the absolute value. It's the value of a number without the sign, basically. So if you say abs minus 3, it just gives you 3. If you do it on a positive number, then it just doesn't do anything, basically. And it also work on a decimal. So if you have minus 1.5, it will give you 1.5. So it just gives you the number ignoring the sign, making it positive. If you want to flip signs, don't forget that you can just multiply a number by minus 1. So multiplying a number by 1 keeps it the same value, so 2 times 1 is still 2. But introducing that negative symbol will flip the sign. So if you do 2 times minus 1, for example, so 2 times, I was thinking, I had my maths head on then, 2 times minus 1, and that will give me minus 2, and then I can multiply it by minus 1 again. So minus 2 times minus 1 brings it back to plus 2. So multiplying by minus 1 is a good way of flipping the sign, and that can mean flipping the direction, for example, within a program without having to know whether it's positive or negative to begin with. So that's quite useful. And then the another thing that's quite useful, again, we talked about turning a number into a string. You can turn a string into a number. So there's text function called eval, and what that does is it takes a string and it checks if there's any numbers in it. But it would also check for a calculation. So you can do things like this. So I can do calc equals input. Give me a calculation to do, and then what I'm going to do is I'm going to print calc, so we see what the calculation is. We'll print an equals sign, and then we'll print eval calc. So now if I run that program, give me a calculation to do, 1 plus 2, it's going to say 1 plus 2 is equal to 3. So it's read in my string, it's evaluated it to see whether it's a valid calculation, and it's actually calculated the result. Obviously, if you do something like eval ABC, it's not going to like it. But if it's a valid calculation in there, it will do it. Let's just have a look at one more thing, which is, what about if I do this? So if I do 1 divided by 3, so it will recognise the standard programming symbols, so asterisk for multiply, slash for divide. So that's given me quite a long answer. So can we round that off? Well, yes, we can. So I'm just going to copy and paste that. So there's a function called round, and what that does is it takes the number that you want to round and the number of decimal places. So if we round that to 2 decimal places, we can round it off like that. So we can either do that as a separate line, or we can do it in line here. So round that to 2 decimal places in my program. And now when I run my program, if I do, let's do a different one. Let's do 1 divided by 6. It'll round it off. So 2 divided by 3, 0.67. So it's rounded it off, and it's rounded it off properly as you would in maths, because 2/3 is 0.6666, recurring. So it's rounded it up to 0.67. So it does it properly. Actually, I'm just wondering whether it will do. I've never tried this. So if I do 2, whether it will do indices. Oh, it does as well, so it can cope with that as well. So that might form the basis of a calculator program. There was a calculator program. It's one of the GCSE tasks a few years ago. So that's a few things. So we've looked at how to do indices, how to convert between strings and numbers, and also between numbers and strings. We've looked at rounding. We've looked at coping with negatives and flipping the sign by multiplying by -1. These rounding obviously applies to floating point numbers. You can run into some problems dealing with floating point numbers. So I've got a neat little example here that I ran into myself. So I had this idea that I was going to create this web page to help my math students with their standard form. So the idea was you typed in a number and you adjusted the power of 10. So 5 is the same as 0.5 times 10 and 0.05 times 2, etc. However, what I discovered was if I put in certain numbers, so 0.3 for example, when I shifted, it did that. And it's because there are certain numbers that you can't represent in binary inside the computer, and the computer struggles with them, and they're not the same ones that we struggle with. So for example, 1/3 is a recurring decimal in our numbering system in denary, but in binary you get kind of recurring decimals with different numbers, so numbers that you're kind of not used to. So there are ways around that. So I did fix that using a combination of mathematical techniques, but that's something to look out for. So when I worked in the software industry, we did software for banks and insurance companies, and obviously there's a lot of numerical calculations involving money, and money is often given to 2 decimal places. It's safer, if you're doing that, to do calculations in pence and work with whole numbers than to do calculations in pounds and work with floating point numbers. So sometimes when you're designing your program, have a little think about whether you really need to do a floating point calculation, or whether you could just multiply all the numbers by 100 for the purpose of doing your calculations and just insert the decimal point at the end.